Our next chapter is trigonometry 1, that is topic 2 in senior 3. What is the competence? The competence there is the learner understands and uses the three basic trig functions. So three basic trig functions, that is sine, cos, and tan. Of course, there are many, but that will be a level work come 2026. Anyway, so here they are telling us that the learning outcomes, finding angles of elevation and depression, uses cosine, tan, and tangent. As we said, this activity of integration will focus on the few, then we'll set more so that you can exhaust all. Okay, in our scenario here, they are saying a community plans to construct a tower on a top of a hill. The base of a hill is located at a distance of 80 meters away from point A. So this is point A. So here we have our 80 meters. Our 80 meters from the base of the hill. This is our hill. Anyway, let me say this is from here up to here is our hill. Then the tower is going to be at the top of the hill, so which we are going to say now from there up to here, that will be our tower. Let me say this is going to be our tower. Okay, they are saying that the angle of elevation from point A to the top of the hill, so the angle of elevation from point A to the top of the hill, here they are telling us that this is going to be 50 degrees, and the angle of elevation from to the top of the tower is 60. So the angle of elevation here is 60 degrees. So when you when you look at the top of the tower, you get 60 degrees. So for safety purposes, the height of the tower should not exceed 50 meters. So this height here should not exceed 50 meters. So they want us to set up the community to know whether the tower can be built safely according to the safety measures. So if they set them from point and they set that, you want to know that is the height of the tower going to be less than 50 for safety measures or for stability. You know, the higher the tower, the less stable it is. So first of all, let me call this one the height of the hill. Let me call it H. So from here, just the height of the hill. Then let me call this one capital H. Just from here to there. Let me call this one capital H. Top of the hill up to there. The tower, top of the tower. Then this one, I call this distance, let me call it just H. So our task is now to get that H. Now, what I'm going to do, I'm first of all going to first get this using that first triangle, as you can see. So I'm going to use this triangle here. So, I extract it out properly. Remember here, it's having 50 degrees, and this one is H. Or here we have 80 meters. So I want first of all to get the height of the hill. Clearly you have the opposite, you have the adjacent, so probably that is going to be tan. So now from here, my tan is going to be the opposite over the adjacent. So I multiply this here, my H will be 80 tan 50 degrees. So my H will be 95.340, which we can remember in distance always to one decimal place. So that is now the height of the hill. Now, how am I going to get the height of the tower? To get the height of the tower, now I'm going to use this triangle here. I'm going to use the big triangle. So using the big triangle, so I extract it out, the big triangle. Remember the big triangle, in there it has many things. Okay, let me maybe make it better. Remember, the big triangle has the height now is going to be h plus small h. So from here up to down, it's going to be capital H plus h. But remember, the angle variation up to here, right, is going to be 60. So the whole of this angle is 60 degrees. So that is still from here, our distance, if this is point A, this remains 80 meters. So here we're also going to use tan. So tan 60 degrees will be equal to the opposite over the adjacent. So cross multiply there, you get 80 tan 60 degrees equals to h plus small h. But remember, you have already our small h here. So meaning, when you press this on the calculator, you have 138.1 decimal place 6 equals to h plus now my small h 95.3. Take this side equals to our h. So there my h will be equals to 43.3 meters. So you see that now the height of our tower is 43.3 meters, which is less than 50. So meaning it's going to be okay. So for stability purpose, determine that the tower will be built safely. Yeah. The tower will be safe since its height is 43.3 meters less than 50 meters. We said you always have to respond to the task. So clearly we have responded, and so we have been able to go through that. Let us move to the next chapter.